So, greetings everyone. So, my name is again Audrey Arlychika, and now I'm gonna explain about the phase diagram, the integration of the Clapeyron equation, and the effect of the pressure on the vapor pressure. So, let's start. So, with the phase diagram. So you maybe had noticed, so the phase diagram is a phase from the matter, from the solid and liquid and the vapor or gases. So in this diagram we have 2 points, so the triple point and the critical point. So the triple point is easy, it's just the balance point between the solid, liquid and the vapor. But the critical point is more complicated, so it's when the density of the liquid and the vapor is same and make them just can it's hard to, how do I spell it, it's hard to measurable, so we just cannot easily find. So well, and yeah, the pressure is here and the temperature is here, and yeah, the solids mean the you can see this is there is the solid part and liquid part and the vapor part. And yeah, overall that's the phase diagram. So let's move to the Clapeyron equation. So in the Clapeyron equation you will see that log n, so the equation is here, P2 per P1 equal to delta H per vapor per R times 1 per T2 divided by T1, and yeah, that's the equation. And yeah, the delta is joule per mole, so it's not a kilojoule. So if you had the kilojoule, you need to convert it first to joule. Why? Because the R is 8.354 is a joule per mole times K, which is Kelvin. So you need to convert the temperature first to from the Celsius to Kelvin, and yeah, it's easy because you just need to add 273 to the temperature of the Celsius. So here's the equation, and yeah, sometimes you will not see this part as the negative but as the positive, so you will see it like this. So well, when you see the delta H here is the plus instead of minus, it's probably because the pressure is reversed. So if the pressure is reversed, P1 reverts to P2 right here, you will see that the delta is, yeah, well, kind of different. And yeah, it's, instead of becoming the negative sign, it's gonna become the positive sign. So then you also can do this for the temperature too. So when the temperature is reversed to, the negative and positive signs here can also be reversed, same as the temperature and the pressure. And yeah, you're probably gonna see this in the overall subject. And yeah, it's probably harder than you think. And next is the other form of the equation, which is gonna be used when you are need to find the feed pressure by adding the new temperature. So you're just gonna write it here. P2 is equal to P1 times E minus delta H vaporization per R times 1 divided by T2, and yeah, 1 per T1. So you're gonna use this when you need to find the feed pressure while adding a new temperature. So to be honest, I'm not really mastering this one, but as I can say to you, it's another form from this. And yeah, you will see much of this in a much different form, depends on the situation. Now sometimes you will need to find the vapor pressure, and yeah, the heat of vaporization. So down when it's come, this is the formula that you will want to use. So the delta H and the liquid of the vaporization equal to R all divided by So this is the formula that you want to use when you need to find the heat of the vaporization. And yeah, sometimes you will need to find, so the second temperature. So this is the formula that you want to use when you need to do that. Ln P2 divided by P1 all divided by the enthalpy of the vaporization. All of this is always negative. So when you need to find the second temperature here, this is the formula that you want to use, and yeah, it's always negative here. And yeah, if you want to find the Kelvin, you simply just like this one, you simply need to add plus 273 to the Celsius. So before you go through the equation. And yeah, next for the effect of the vapor pressure. So as the temperature of the liquid or the solid increase in the vapor pressure, also increase the conversely vapor pressure decrease as the temperature decrease. So when the pressure is high, and then the temperature of the liquid is also gonna just as high as the temperature. So it's maybe sound simple, but there's a much of ways that you can to measure the pressure of the liquid and the gas in the vapor pressure. And yeah, last but not least, the phase rule. So the phase rule, so you must be in the first know what the phase diagrams look like, right? So here, so the phase rule is simply the phase of the general principle of the governing system in the thermodynamics equilibrium. So what it means that if F is a number of freedom, C is a number of the components, and P is the for pass. So oh, I'm sorry, the number of the passes. So it's the passes rule. So when you are dealing with the passes, you will need to use this alphabet. You need to know the meaning of the alphabet. So the meaning is the F for the number of freedom, C is the number of components, and P for phases, the number of phases. So it's all. And yeah, I mean the phases, right? Okay, maybe that's all for this time. And yeah, I'm sorry if you don't understand, because I probably don't understand it much either. And yeah, see you next time.